So we're going to start off here and we'll do the first one. Now, I gave you a hint right here, and obviously this hint won't be given on test quizzes or next year in calculus, but here they're telling us to use SOHCAHTOA. And then there's a reason why we have to be in degrees mode. Now, that isn't always the case. And actually, when you're in calculus, you're going to be in radians for the entire time. So it's a different mode, and we'll show you that. But to start here, in the first triangle, they give us a 90-degree angle. And when you do trigonometry, you have to have the 90-degree angle. If you don't have the 90-degree angle, SOHCAHTOA will not work. And then we know angle B is 75 degrees and the length CD is 97 feet. Find the length BC to the nearest tenth of a foot. If this was calculus, they would really have you round to the nearest third decimal. So that's something just to keep in mind. So how are we going to approach this? Well, here's my angle of reference. And across from that is the side length. That is the opposite side. And then the x is in the opposite. So what do we have? We have opposite and hypotenuse. I have the SO, which is going to set up the sine ratio. Sine of the angle theta, well, in this case, we're not going to call it theta because we know that it's 75 degrees. So sine of 75 degrees is the ratio of the opposite side over the hypotenuse. And then our job is to just solve. What I like to do is set up a fraction equals a fraction. We have a ratio, which means we're going to cross multiply. Now there's two ways to do this. You can do 1 times 97 and divide by sine of 75, or you can just switch the spot of the x and the sine so it looks like this. And that's one of the properties of solving ratios is you can just switch two spots. In this case, we switch the x and the sine of 75. And the reason why we do that is in my calculator now, I'm just going to take 97 divided by the sine of 75. So first thing I need to do is I need to make sure that my calculator is in degrees mode. How do I know that I should be in degrees mode? Well, notice we're doing the sine of 75 degrees. That little degree symbol indicates which mode I need to be in. So hopefully you're comfortable changing the mode. Hit mode, go over to degrees and hit enter. And then I'm just going to do 97 divided by the sine of 75. And I get 100 point, now this says round to the nearest tenth of a foot, so the 2 would leave the 4, so I'd be 100.4 feet. All right, so this was just the regular use of SOHCAHTOA. We ended up using the sine ratio because we had the opposite and the hypotenuse. And notice we were given the angle. Well, number 2, they actually tell us to find the angle. So we have to think a little differently about this problem. We're still going to use SOHCAHTOA to help set up the problem, but then we have to work backwards. So, well, what do we have to do? We know that we have our angle of reference at x, and we're given the hypotenuse, which is always across from the 90 degree, and we're given the side next to the angle, which is the adjacent side. So I have the A and I have the H. Well, the only one that has A and H in it is cosine. And its cosine of the angle x is equal to the ratio of the adjacent side, which is 26, over the hypotenuse. Now you'll notice this is different than what we have here. We have to find the value of x, which means I have to get rid of a cosine. So the only way to get the x by itself is to take the cosine inverse of both sides. And I usually only write it to the left side because if I did the cosine inverse of cosine, those reduce out and leave me with x. And then the cosine inverse of the ratio of the adjacent over the hypotenuse is just the value that I'm going to plug into my calculator. Now, notice they say find the angle f to the nearest degree. That's a hint that we need to remain in degrees mode. So what I'll do then is just start, and we want cosine inverse. That's that little -1, and that's the second cosine. And then you just type in the ratio 26/95. Hit enter, and then that will give us, and they say round to the nearest degree. So the 1 would basically round this up to 74 exactly. So the measure of angle X is 74, and then we should put the degree symbol because we know it's in degrees. All right, quick little note here. I want you to please take this to heart. If you have not mastered these two questions from Algebra 2, then there is an optional assignment in Delta Math called 4.0. It works through these two problems. You can actually probably tell I actually screenshot these two problems exactly from Delta Math. It gives you more practice. You will have to know how to do these questions. They will appear on a test and a quiz. We'll do them as they pop up, but we're not going to do these just solely on our own because we've already learned them. And when you get to calculus, it is assumed that you have absolutely mastered this. So that's where you need to put in the extra work now if you need to. If you've already mastered it, then you're good. All right? So one little hint I like to say is just whenever you're finding a length, a hypotenuse or an opposite or adjacent side, whenever you're finding length, use regular SOHCAHTOA. Anytime you have to find an angle, you have to undo a ratio, which is our inverse trig. So that's kind of your indication of how these two problems differ. All right. I want to just point this out right now. Juniors, we are going to be talking about registration for next year regarding math classes, but we're going to do that at the end of class because we've got mostly seniors in this class. I think I only have about 7 or 8 juniors. So juniors, I'm going to ask, we're going to finish a little early today, but I'm going to ask that juniors, you stick around for the last 15 minutes or so we can talk about registration. Okay? And hopefully you've already talked some about registration in your first hour because that was the expectation of first hour. And then we have a video to watch for this hour, and I'm going to give you math specific courses that you can register for next year. All right, but we are going to start and we're going to kind of talk about what is this whole idea of radians and degrees and degrees and radians, and why do we have different modes in our calculator? And what do they mean? So that's the first part of today, is to just distinguish the difference between radian and degrees. And we can convert between one measure and the other. Really, they're just different ways to measure the size of an angle. And then the other part is something called arc length. And you might remember arc length from geometry. We actually learned how to find arc length in geometry, but now that we know what radians are, arc length is a very fast calculation because of what we know about radians. So that's why this fits in with the lesson today. Okay, we're going to start off with this piece right here. I do not want you to write this slide. You're going to think you might want to, but on the next slide, we have everything that you need. All right, so let's just start off with this first part. How do we measure parts in a circle? Well, we have the radius, we have the diameter, we have the length of arcs, all those things we've studied, and everything was really based off of a degree measure. So what is a degree? Well, 1 degree is the angle formed when a circle is divided into 360 equal parts, and that was the way that we divided it up. Right? A circle has 360 degrees, so 1 degree could kind of look like this. This is a small part. If I had 360 of these all stacked up on top of each other, it would form a full circle, right? We've known that for a while. So what is this idea of a radian? Well, I want to show you this, and this is just a visualization piece of what is a radian and how does it work. So I'm going to kind of stop this as we go. So let's take a look at, whoops, here's what we got. Let's start off with a dot. And what if I draw a line? And it's not working right now. Try this again. Here we go. So what if I draw a line? what is that? Well, that's a length, right? And then if I keep drawing that line in a circle, that gives me a circle, and that's our radius length. So watch what happens here. We use the radius and swing around all the way around until we get back to where we started, and that's what created our circle. But that radius, what if I take the same length of this radius right here and I extend it up? So these blue lines are equal in length. And then what if I wrap that radius around the circle? Okay, right there, it stops. Right? So this length in blue is the same length as the radius. Okay, now what if I connect that? What happens is we actually have a sector. We talked about that in geometry. That was just like a piece of pie, right? Well, that piece of pie has an angle measure. And what this angle measure is, it's actually 1 radian. So instead of calling this a certain amount of degrees, it's 1 radian, which is the length, when the arc length, the distance around the circle, when this length is the same as the radius length. So watch what happens here. And I guess my question to you is, how many of these blue sectors do you think it's going to take to get back to where we started? Right, so kind of just a guess to yourself, how many of these blue sectors would it take to fill up this circle? Well, let's look at it. What if I extend this out and I do 2 radians? So there's another radian. And notice 3 radians gets me almost halfway around the circle. Now that extra little bit right here, 1.4159. Wait a minute. How many total radians is that? It's 3.14159. 3.14159. Isn't that a very special number? It is. It's the same as pi. You guys know what pi is. Pi is that irrational number that goes 3.1415928, and it keeps on going forever and forever. This is a visualization of pi, right, in reference to radians. So this is a fact that we need to know. 180 degrees, halfway around the circle, is equal to pi radians. All right, so 3.14159 of these radian lengths. Well, then what would it be if I went all the way around the circle? So here, notice they're going another certain radian amounts. They go all the way around the circle. So they go another pi radians. Well, how many total pi radians are there? All the way around the circle, there are 6.28 radians. Well, wait a minute. 2 times 3.14. Well, this is going a little bit faster. 2 pi is all the way around the circle, and that's equal to 360 degrees. So if 1 pi was equal to 180, double that, 2 pi is equal to 360. And then the length is 6.28 radians. Remember, radian is the length of the radius. So how many of these radii lengths would it take to get all the way around the circle? It would take 6.28 of the radius lengths. Now what happens if I make this radius longer? If it gets longer, it still has the same amount of times around the circle because the circle's circumference gets bigger. So that's the idea, is there's a connection here. And I think I paused it, so it's not going to go. But it just says here the radian measure is the ratio of the arc length to the radius itself. So let's say I go all the way here, and the arc length is 12.29, and the radius is 7. Well, 12.29 divided by 7 gives me 1.76 radians. And that's the size of this angle in radians. Okay, and if I keep going, you could see that if I go all the way around the circle, the circumference of the circle is 43.69. If I divide that by 7, we get 6.28, which is 2 pi. All right, so that's a visualization of what we're going to be talking about here. So let's think about this right now, and we're going to make a little connection. You do not have to write this because it's on the next slide. But what do I know? it said that if pi was equal to 180 degrees, right? Now this is pi is what we call the radian measure, and then the degree symbol, or we could write degrees. Well, what if I want to figure out what is 1 degree equal to? Right? All I do is divide both sides by 180. Because if I divide by 180, 180 over 180 is 1. And that means that pi divided by 180 is how I get the degree. So if I have something in a degree, or if I have something in radians, I could actually convert it to degrees using this relationship right here. Okay? Or what if I flipped that around? Right? What if I had, we know that pi is equal to 180 degrees. So what if I wanted to figure out what 1 radian is equal to? So I divide by pi. That would leave pi over pi is 1, and that's radians. So 1 radian is equal to 180 over pi degrees. And I know this doesn't make a ton of sense yet, but it will. Those are my two conversion pieces. And it's basically the idea here. 1 radian is the angle formed between the length of the arc, between the two radii, and it's equal to the radius. That's what we talked about here. All right, so I liked that visualization piece over kind of just thinking about it hypothetically. So that's the big piece here, is this length r is the radius, and the arc length is a portion of that piece. And if the s and the r are equal, then this angle right here is 1 radian. Okay, so don't write this either. This is just a visualization piece, and then on the next slide we'll have what we want to write. So let's think about a couple of things, and how do we break this circle up? Well, in 0 degrees, that's pretty friendly, right? We can split that up kind of nicely. If I look at degrees, notice the symbol here. Degrees. At 0 degrees, if I go halfway around the circle, that's going to get me to 180, right? And if I go another half, that's going to get me back to where I started. So this is called a coterminal angle, where the 0 and 360 are in the same spot. Nothing crazy, right? But what if I do half of 180? Well, half of 180 is 90. And what if I do half of, well, and I go another, so I go 90, another 90, and another 90. That puts me at 270 degrees. And these are called the 4 quadrants or quadrantial angles. And those are pretty important in calculus. You're going to see those come up a lot. So what about radians? We had said halfway around the circle was equal to pi. So if I start at this spot, that's considered 0 radians. If I go halfway around the circle, that's pi. And if I go another half, then that's going to get me to 2 pi, which kind of shows us that 360 degrees is equal to 2 pi. Well, what if I only go half of the way? Instead of going all the way to 180 and going pi, what if I cut that in half? What does that look like? That's considered pi over 2. So this is pi over 2. Technically, I could write this as 2 pi over 2's, because if I go 1 pi over 2 and another pi over 2, that's 2 pi over 2, but those 2's go away, which is considered pi. Well, what if I go another pi over 2? That's considered 3 pi over 2. Right? So we're just thinking of it fractionally. And we could actually even go further if we wanted. I'm not going to get too far into this, because we're really going to cover it much later. But what if I cut that in half? What if, instead of going 90, what if I go half of 90? Half of 90 is 45 degrees. So what if I take this pi over 2 and I cut it in half? Right? So I'm going to multiply by 1/2. You multiply straight across. That's going to give me pi over 4, right? 1 times pi is pi, 2 times 2 is 4. So 45 degrees is the same as pi over 4. So notice, technically, every time I move 45 degrees, hold on. There we go. Oh no. Hold on one second. Okay. So just really quick, if we go 45 degrees, that's 1 pi over 4. If I go another 45, that's equal to 2 pi over 4. But 2 over 4, isn't that the same as 1/2? So we don't write it as 2 pi over 4, we just write it as pi over 2. And then if I went over here, oh boy, this is going to be not nice. If I go another pi over 4, if I go another pi over 4, that's 1, 2, 3 pi over 4. So right here, I'll get 3 pi over 4, and that doesn't reduce down. But if I go 4 pi over 4, 4 over 4 is the same as pi. So you can kind of see how we're breaking these up in radians. And that's basically saying it's all based off of the fact that pi is equal to 180. So the question we have here is, how many degrees are in pi? Well, that's just looking at this and saying there's 180 degrees in pi. How many degrees are there in 2 pi? That's all the way around the circle. So all the way around the circle, well, 2 pi is 360 degrees. Right? But then we got to start talking about radians. And how do we deal with radians? Well, how many radians are in 180? Radian is considered the pi. So we have pi radians in 180. And then how about if I double that, right? Because if I double 180, I get 360, and 360 is 2 pi. And then how about 90 degrees? We kind of found that if I went half of the way to 180, if I cut that in half of pi is pi over 2. So this is just the theory side of it and how it looks visually, but there's a kind of a better way to do this. Okay, so what I'm going to do is show you how to convert. I would like you to write this part right here. All right, so you guys are writing this part here. I just want to quick show you where this came from, because sometimes students get confused on, well, wait a minute, why is this the way it is? Well, what if I just move this pi over to the other side? So don't write this part right here. But what if I take pi, and instead of doing 180 divided by pi, what if I times pi over to this side? So I'm not going to show that step, but what happens is I get 1 times pi is equal to 180 degrees. Well, and that's the fact that we just kind of saw, is halfway around the circle, 180 degrees is equal to pi radians. So I can use this fact, and I can move, if I want to find the radians, I can divide by pi. So I get 180 over pi, and that tells me how 1 radian is equal to a degree. Or instead of moving the pi over to the right side, what if I take the 180 and move it over here? So what if I divide by 180? Well, 180 divided by 180 is 1 degree. And that tells me pi over 180 is radians. So that's where this conversion rate comes from. All right, this is on the next slide, so if you didn't fully write it down, what we're going to do is we're going to just look at a couple problems. How do I convert between degrees and radians? And here's the same thing that was on the other slide, right? So our goal is to convert 30 degrees into radians. And once you get really good at this, you're going to know the answer very quickly. It gets a little harder with bigger angles, but the process is the same. So these two are in degrees. We know that because of that little degree symbol there. So we want to convert them to radians. Now look at over here. This has pi in it, so it obviously is a radian measure. If there is no degree symbol, then it's automatically assumed that this is radians. All right, so let's work through this piece right here. How do I want to take the 30 degrees and turn it into radians? So I want to look and see, well, what is each degree equal to? Each degree is equal to pi over 180 radians. So I'm going to take the pi over 180, and we're going to multiply the degrees by the amount of radians. Now think of this as 30 over 1. All right, so what that does is that tells me I'm just multiplying fractions, and when you multiply fractions, you go straight across. I end up with 30 pi over 180. Okay. Then think of this as reducing fractions. Now, keep in mind, we want pi to stay in our answer, and then I'm just going to divide each one of these out. You might know quickly what it goes into, but I know that they each are divisible by 10, which gets rid of the zeros. And then I'm left with 3 over 18. But 3 over 18 is 1/6, right? 3 goes into 18 6 times. But I don't need the 1 up top because there's a pi there. So there's my answer. 30 degrees is equal to pi over 6 radians. And that's something you could memorize, by the way, if you just kind of a quick little thought process. Remember when we did 30, 60, 90 triangles? Well, we, in calculus especially, this 30-degree angles is also the same as pi over 6. So if you see pi over 6 here, you can think of it as 30 degrees. And we'll get way further into special right triangles and something called the unit circle later on. But all we want to do is go from degrees to radians. Okay, the next one. I have 110 degrees. Well, it's in degrees. I want to convert it into radians. So I want to get pi back into my answer. So I'm going to multiply by pi over 180. And again, I always make this a 1. And then you're just going to multiply straight across. So you got 110 over pi. And then, 110 times pi over 180. And then you're going to reduce basically the same way. Notice 110, that's divisible by 10, and 180 is divisible by 10, which basically cancels 1 0 out. And I'm left with 11 over 18. 11 over 18 does not reduce down, so I'm going to leave it as 11/18. And then what we do is we put the pi back in our answer. Most of the times you're going to see it written like this, but there's nothing technically wrong if you write the pi on the outside. These are equivalent radians. And you don't technically have to write the word radian or the abbreviation for radian. I do, but if there's a pi in it, you know that it's a radian. If there's a degree symbol, you know it's degrees. Okay? I would prefer it to be written this way, where pi is in the numerator. This is like 11 times pi. Or you could do 11/18 times pi. They're equivalent. Okay, so what about the radian measure? Now I have radian. I want to turn this into a degree. So I think of it, there's 2 ways to do this. I'll show you kind of the conversion way, and I'll show you another way and see which way you like it. What we need to do is we need to get rid of the pi. And the only way to get rid of the pi is to multiply by 180 over pi. Watch what happens. When I times by 180 over pi, what happens is the pi's go away, right? The pi on top, pi on bottom go away, and then you're technically just going to multiply straight across. You're multiplying fractions. So 5 times 180 is 900. And technically, if that reduces out, there is a 1. So I get 8 times 1 on the bottom, or I get 900 over 8. That's not wrong. That's technically correct. But what we can do then is just do 900 divided by 8. And we get the amount of degrees. I always like to round it to at least a tenth. Sometimes I go 3 decimals. But notice I put the little degree symbol there. So I went from radians to degrees. Technically, 5 pi over 8 is 112.5 degrees. Okay? Another way to think of this is, and you don't have to write this part. I'm just going to kind of show you down here. So another way to write it is 5/8 of pi. Well, wait a minute. Didn't we just say what pi was equal to? Right? Isn't pi the same as 180? So if you're ever converting from radians to degrees, you technically can just plug in 180 for pi, and you'll get the exact same thing. Now, so these are 2 different ways to do it. Because 180 is equal to pi, you can just plug it in. When I get to a problem like 4.8, technically this is in radians, right? Because there's no degree symbol, so this is in radians, and we want to change it to degrees. Well, the method that I talked about here, whereas if you see pi, just plug in 180, we don't have a pi in here. So that's where we have to rely on the conversion, and that's why technically, if you just want to practice these conversions, that will work every single time. Okay, so what do? How do I take radians and turn into degrees? We times by 180 over pi. But technically this is 4.8 over 1. And then you're just going to multiply straight across. It's fractions. So 4.8 times 180 is 864. And then multiply straight across, 1 times pi is pi. And then we're going to ask that you use the pi button in your calculator. Don't use 3.14. That's not accurate enough. We want to use the pi button. So I'll show you where that is if you don't know on your calculator. And then I always like to round to at least a couple decimals if they don't tell me. If I round this one to 3 decimals, I get 275.020 degrees. Right, so let me quick show you, if you need it, where this is on your calculator. So I just want to do 864 divided by pi, and you can see that pi button right there. So I'm going to go second the caret up symbol, or the pi button. And then there's my answer. Notice the 7 would round the 9 to a 10, and then that would round this to a 0.20. I round to 3 decimals. So that's the first part of your homework tonight, is just converting using these relationships. It's pretty quick, and if you need more explanations, Delta Math has some help videos. You can kind of go through and watch those. But now that we know how to convert from degrees to radians, that actually allows us to find something called arc length. So we're going to do this fairly quick. Please, please, please write this part down. And I want to just kind of give you a quick oversight of what do we mean when we say arc length. If you remember from geometry, arc length is the length of the curved part of the circle. Right? So this arc right here, how long is it? Well, when we learned it in geometry, it was a certain proportion or ratio of the circumference. Right? So it was a certain amount of the entire circumference, but that's what we mean by arc length. Arc length is the distance around the circle. Well, how do we find that? It's a really quick formula if you know how to convert an angle measure into radians. So here's what we got. All it is the arc length is equal to the radius times theta. Now remember, theta is a Greek letter. It doesn't technically need to be theta. It could be alpha, beta, gamma, anything like that. It just stands for an angle measure. But r is the radius, and the radius is from the distance from the center to the rim or the edge of the circle. So it doesn't matter where they write it, but as long as you know the radius and you know the angle measure between them. So what is the measure of the angle between the two radii? We don't want that in degrees. If they give it to us in degrees, we have to convert it into radians, and that's the only thing you have to be aware of. This is a really quick formula. If you convert this angle measure into radians, sometimes it's given, and then you just multiply it by the radius, and that's your arc length. Or sometimes it's given in degrees, and you have to convert it first, and then multiply. So you can kind of see why and how this fits into our examples today. All right, I'll give you another minute to finish writing that down. So let's do some real quick problems here. So find the arc length with the given measurements. Theta is equal to pi over 6. Notice that is definitely in radians because pi is in the answer. And then we have the radius. This is about as quick and friendly as these kind of problems get. So arc length is just multiplying these two together. We always use S as our arc length. So what is it? It's 3 times pi over 6. Now we want to resist the urge of just grabbing a calculator. A lot of times they're going to ask for exact measurements, and in that case, that means leave pi in your answer. So in this case, if I have 3 times pi over 6, that's really 3 over 1. And then we're multiplying straight across with fractions. So it becomes 3 pi over 6, but then 3 over 6 reduces down to 1/2, or pi over 2. And then notice, this is a length, right? And they tell us the units are in centimeters, because if the radius is 3 centimeters, then the arc length also has to be in that. Quick visualization, what did we just do? Okay, you don't have to draw this picture, but let's say I have a circle and I have a radius of 3. Well, what did we do? We found an angle measure here where we have both radii, and then here's theta. That's pi over 6, which is pi is 180. 180 divided by 6 is really 30, so this is like a 30-degree angle right here. But what did I just find? I found the length of this arc right here. That is S, and S is pi over 2 centimeters long. Right? And you could take pi, which is 3.14, and you could divide that out. So if I'm going to use the pi button, just take pi and divide it by 2. That means that the length of this part of the circle is 1.75 centimeters, but we want the exact measurement versus the rounded. All right. Now notice the difference here. This is the only spot that students get in trouble with. They see theta, they see the radius, and they think, cool, I'm just going to multiply them together, and they're going to get their answer. Well, we have a small problem here. My angle measures in degrees. I can't have it in degrees. I have to convert first. So what I need to do is I need to take this 36 degrees and I need to put pi back into the answer. So we're going to multiply it by pi over 180, just like we did on the other slide, to convert it into radians. Right? And then think of this as 36 over 1 times pi over 180. You don't need to show this work right here. But I'm going to take 36 and divide it by 180. And I'll show you a quick way to do that on your calculator here if you aren't positive. So I want to do 36 divided by 180. And I want to turn that back into a fraction. So remember the math button in your first option is fraction. Hit enter. That's 1/5. So 36 goes into 185 times. There is my theta in radians. So then we can take and find the arc length. The radius is 6. We just found theta is pi over 5. And if they were asking for our exact answer, remember that's like 6 over 1. Multiply straight across, you get 6 pi over 5. And then the units would be feet. There's my arc length. But what if they want a non-exact answer? How would you do this? And there's a couple of different ways to do it. You have to be careful in your calculator. I can't type it in as 6. Watch what happens here. If I do 6 pi divided by 5, if I type it in like this, that is incorrect. It's going to do 6 times pi. Actually, I believe that's incorrect. It should be, just for safety, you should do it like this, where you put the numerator in parentheses and then divide by 5. And actually, it does because of, I'll show you another way where it doesn't work like this. But you just got to be careful, right? Anytime you have more than just a number, use parentheses. But I could also do it like this. Remember how we said we could put the pi on the outside, and I could do 6/5 and then times by pi? They're basically all the same, but sometimes we got to really be careful with this. So 3.7, I already forgot. 3.770 is what I would round it to. So here's my rounded answer, but in Delta Math, they may ask you for the exact answer. So you would just say 6 pi over 5. All right, we've got one more slide left, and then I got to talk to the juniors about registration. So what if we're working backwards? Okay? And that's the only other way we could get this is, notice they give us the arc length, they give us the radius, and they want us to find the angle measure. Okay? And then same thing here, they give us the arc length, we want to find the radius, and they give us the angle measure, but notice how that angle measure is written. So we'll do these pretty quick. We have to start with what we know. Arc length is the radius times theta. Arc length is 12.8 yards. The radius is 3.4, and theta is, you can think of theta the same thing as x. It's a variable, right? So nothing crazy here. It's a real quick one-step problem. I need to get 3.4 over to the other side. So I'm isolating theta. And then I'm going to do 12.8 divided by 3.4. And I always recommend rounding to, unless they tell us, which they didn't here, I always say round to 3 decimals. So 3.765. Now, we got to keep in mind that answer is in radians, right? Because the arc length is calculated when theta is in radians. Okay. And then the last one, arc length is 132 inches. I don't know the radius, but this time I know theta. However, theta is written in terms of degrees. We need to convert into radians. So I need to put pi back into the answer. Which just means I have to times by pi over 180. And that will put pi back into my answer, or back into the angle. And you could enter it just like this. You technically don't have to reduce this, but I'm going to show you how I would reduce this. I'm going to leave pi right where it is. And then I'm just going to grab my calculator and do 225 divided by pi, or excuse me, divided by 180. So just take 225 divided by 180, hit enter, and then turn that back into a fraction. So hit math and option 1, and then enter, and it'll take the 1.25, which you probably already knew what that was, but that gives me the 5/4. There's the theta in radians that we need right here. So algebraically, how do I get rid of the 5/4? Well, let's do this in a couple steps. There's a couple ways you could do it. You could times by 4 and then divide by 5, or at the same time, let's just multiply by the reciprocal, which technically this pi is in the numerator, so I'm going to times both sides by the reciprocal. And what that does is it gets rid of the 5 pi on top and on bottom, gets rid of the 4 on bottom and on top. So it leaves r, and then now we're just multiplying fractions again, right? Numerator times numerator. So 4 times 132 over 5 pi. And notice, this is a 5 right here. 5 is not going to go evenly into a number that ends with an 8. So I know that this is most likely, this is reduced as far as it can go. So this would be the exact answer. And do keep in mind, this is a radius, right? If the arc length was in inches, then this radius would be inches as well. But that's not super common, right? You're not going to, if you were actually trying to measure this out, you would want to know what the decimal answer is. So here's where, watch what happens when I check this in my calculator. Okay, this is where parentheses are really important. What if I just typed it in like this? Okay, now I'll just tell you right away, this is not my answer, but I see a lot of students do this. 528 divided by 5 pi. If I hit enter, okay, I get a number. Cool. That seems really big, right? The radius is way bigger than the arc length, but I'm not sure if that's right or wrong. But it's technically wrong because you didn't divide by 5 pi, you just divided by 5, and then you times by pi. So if you're using your calculator, you need to put parentheses around the denominator. Watch what happens. That's a significant difference right there. All right, so there's two ways you can do this. I like the parentheses Some people like to do this. They like to say, take 528, I'm going to divide it by 5 first, and then I'm going to take that answer and divide it by pi. It's longer, but notice I get the same thing. So big thing, put parentheses around the denominator, and you'll be good. But either way, you should get 33.614 if we round that. So 33.614. And that is the length of the radius in inches. Okay, so be careful. If you have the arc length and you're working backwards, your angle has to be in radians first, and then it's just algebra. So here's what we got. Please do not log off yet. I want to make sure everybody understands what's going on. So homework tonight, when you open it up, you're going to see 4.1. That's the homework for tonight. Do it, submit a screenshot to Schoology. The warm-up we did was 2 problems based off of trigonometry. And if you look in Delta Math, there's an optional practice 4.0a. It's called right triangle trig practice. If the warm-up didn't go well, or you're not confident in that, then you should really work through this optional practice. Remember, it is assumed that you know how to do this, and it will appear on test quizzes and a lot of things this year and next year. So if you need to do that practice, you should do that on your own. Okay? On Wednesday, your goal for Wednesday is to register for classes. So that's juniors. Seniors, that means on Wednesday, you need to just log in and make sure that you've checked in for attendance. And if you've done everything, seniors, current seniors this year, you don't have to register for next year in high school. So, juniors, I need you guys to stick around, and we're going to talk about registration really quick. Current seniors, you are allowed to leave right now because you don't need to know this. All right, we have 2 things to talk about. I'm going to give you a video that's about 9 minutes long. So juniors, you are going to have to watch this video. It talks about how to sign up, and it's really important because you guys are doing this online, and there's not a lot of engagement here, so it's kind of on you. However, I can help you determine what math class you should take for next year. Your counselors can help you register because this is all online. It's kind of a newer system for us that basically we want you to do that. So anyways, let me show you this. Here's where we're currently at. And if you want to take a screenshot of this in a second, I'll show you what I think you guys, so current 11th grade, right now you're in pre-calculus. You have multiple options for your math class for next year. And I have to say this, if pre-calc is going very well, like this is easy, you're doing it all on your own, you're not using photo math for anything, and you got this and you feel like you've mastered the concepts, and you want to go into a science major, my recommendation would be either AB calculus, I teach that, or BC calculus, and Miss Hires teaches BC calculus. So those are kind of the natural progressions if you want to go into a major that's science or math related. Okay, if you're going into the medical field, that also would be something we recommend. Now, if pre-calculus, if you're struggling with it, or it's not going well, or you've used some resources that maybe you shouldn't, AP Stats is probably the next route for you guys to go. Now, AP Stats is really good for the social sciences. If you're going into, well, I'll just say this, any career, study statistics, right? So using statistics is very helpful. This class could help you for any career you choose. All right. The other options you have are if you want to go into computer science. Okay. Mr. Stutzman teaches the computer science. This is 3 trimesters, or the CS principles, which is 2 tries. I think if you are interested in anything with computers, this would be a great option. I don't know a lot about the class, to be honest. I know they do coding, they use different scripts, JavaScript, and some other ones, but they really kind of give you the good insight. But you have an option. You could either do a 3-try class or a 2-try class, or you also have a 1 trimester elective, which is computer programming, which is a concept of prob and stats. I believe these are two different ones. So you could do computer programming or prob and stats. The danger in doing these or electing these is that if not enough people sign up for them, it's not guaranteed that that class will be offered. However, register for it because you never know. So that's my advice. If pre-calculus is going really easy and you've done it all on your own and you are going into the science fields, do calculus A, B, or BC. Now, what's the difference between A, B, and BC? AB is we teach it, it's a 3-trimester course in high school. And if you pass the AP class exam, you will earn a credit for a semester worth of college calculus. BC is earning 2 semesters worth. It's like doing Calc 1 and Calc 2 in college. So both of them are a 3-trimester class. This one we just go a little bit slower and we cover things a little more in depth. BC goes much faster and they make assumptions that you really mastered the skills that you had before. Okay, so if you want to take a screenshot of this, you may do so. I need to, in the chat, I'm going to send you guys so all juniors, I'm going to send you a link for a video to watch. So just give me 1 second here. I got to go back to this slide so you can take a screenshot. And I will send you a link, and I'm going to ask that you watch this. It's 9 minutes long, and then that's all we got. All right? So if you don't have any questions and you received the link, click on that link before you log out of Zoom right now. Open that up and watch it, and then make sure you do the homework tonight, 4.1. And that's all I got. Have a great day. If you have further questions, I can stick around for a couple minutes, or I'll be in my office hours from 1 to 2 today.